Hello everyone, this is Jahnavi. I am from third year CSCP. Now I am going to discuss with you about riding the data highway, exploring buses in computer organization. Now let us see the contents. Introduction, what are buses, types of buses, bus width, bus speed, arbitration, bus protocol, bus standards, and finally conclusion. Now let us see the introduction part. Welcome to everyone in our presentation on buses in computer organization. Today we will be exploring a critical component of modern computing that often goes unnoticed. Buses are the unsung heroes of the digital world, responsible for connecting various parts of a computer and allowing them to communicate with each other. Without buses, our computers would simply not function. In this presentation, we will delve into the different types of buses, their functions, and how they impact system performance. We will also explore bus width, bus speed, and arbitration, bus topology, bus protocol, and bus standards. By the end of this presentation, you will have a comprehensive understanding of buses and their importance in computer organization. Now let us see what are buses. In computer organization, buses are a communication system that allows data to be transferred between components of a computer. Think of it like a highway that connects different parts of a city. The data travels on the bus just like cars on a highway, allowing different parts of the computer to communicate with each other. The purpose of buses is to provide a fast and efficient way for components to communicate with each other. Without buses, each component would need to have its own dedicated connection to every other component, which would be slow, inefficient, and expensive. Buses allow for a more streamlined and cost-effective approach to computer design. Now let us see the types of buses. In computer organizations, buses are used to transfer data between different components of a computer system. There are three main types of buses: data bus, address bus, and control bus. The data bus is responsible for carrying data between the CPU and memory or other devices. The address bus is used to specify the memory location where data needs to be read from or written to. Finally, the control bus carries signals that control the flow of data and coordinate the activities of different components. Let us discuss about what is bus width. Bus width refers to the number of bits that can be transferred simultaneously on a bus. The wider the bus, the more data it can transfer at once, resulting in faster data transfer rates. For example, a 32-bit bus can transfer 32 bits of data at a time, while a 64-bit bus can transfer 64 bits of data at a time. The impact of bus width on performance can be seen in real-world examples such as video editing and gaming. Video editing software requires large amounts of data to be transferred quickly between the CPU and memory. So, a wider bus can significantly improve performance. Similarly, gaming requires fast data transfer rates to render high quality graphics. So, a wider bus can result in smoother gameplay. Now let us discuss about what is bus speed. The speed of a bus in computer organization can have a significant impact on the overall performance of a system. Bus speed is measured in megahertz or gigahertz, which represents the number of cycles per second that the bus can transmit data. A higher bus speed means that data can be transferred more quickly, resulting in faster processing times for applications and programs. For example, if a computer has a bus speed of 800 megahertz and another has a speed of 1.6 gigahertz, the latter will be able to transfer data at twice the rate of the former. This can make a noticeable difference in the performance of resource intensive applications such as video editing or gaming. Now let us see what is bus arbitration. Bus arbitration is the process by which multiple devices on a bus compete for control of the bus. It is necessary in computer organization because without it, two or more devices could try to access the bus at the same time, causing data corruption and system crashes. To prevent this, bus arbitration protocols are used to determine which device has priority access to the bus. One example of a bus arbitration protocol is the round-robin method, where each device takes turns accessing the bus. Another example is the priority method, where certain devices are given higher priority access based on their importance to the system. Now let us see what is bus protocol. Bus protocol is a set of rules and procedures that govern the communication between devices on a computer bus. It defines how data is transmitted, received and acknowledged, ensuring that all devices follow the same standards for communication. Bus standards. Bus standards are an essential part of computer organization, providing a common interface for different devices to communicate with each other. There are several bus standards in modern computers, including PCI, USB, and FireWire. PCI means Peripheral Component Interconnect. Is a high-speed bus standard commonly used for connecting expansion cards such as graphics cards and network adapters to the motherboard. USB means Universal Serial Bus is a widely adopted standard for connecting peripherals like mouse, keyboards, and external hard drives to a computer. FireWire, also known as IEEE 1394, is another high-speed standard used for connecting devices like digital cameras and external hard drives. Let us see the conclusion. In conclusion, buses are a critical component of computer organization that facilitate communication between different devices. We discussed the different types of buses including data, address and control buses and how they work together to transfer information within a system. We also explored the importance of bus width and speed as well as bus arbitration, topology, protocol and standards. Understanding buses is essential for anyone working with computers, from hardware engineers to software developers. By grasping the fundamentals of buses, we can design more efficient and effective systems that can handle increasingly complex tasks. So let's continue to explore this fascinating topic and push the boundaries of what is possible in the world of computing.